But hey y'all, well this is trial number 3. My brain isn't working this afternoon, so hopefully I'll get it together this time. We are talking about systems of equations again, and we are still talking about combination elimination. And today is March 1st, so it would be wonderful if you would put all of that on your paper. The first problem that we're going to do today is just like the problems we did last night. We have negative 3x minus 8y equals negative 24. And we have 3x minus 5y equals 4.5. Now, combination means that we are going to combine them, and elimination means something is going to cancel. When you combine these two equations, you should see automatically that the negative 3x and 3x cancel. Negative 8y and negative 5y are going to give me negative 13y, and negative 24 plus 4.5 does give me 19.5. Now, I know some of you are going to want to put that in your calculator because you don't believe me, but you can check me out. You can always pause the video if you're interested in having a second longer. Now, we have to divide both sides by negative 13, and we see that y is going to be equal to 1.5. A negative divided by a negative is a positive, and 19.5 divided by 13 does give me 1.5. There goes Dorothy, leaving Miss Peters' room. Say goodbye, Dorothy. So now I have the first coordinate, or the y, so I have 1.5, but I need an x. I don't have my final answer yet. Doesn't matter which one of these equations we use. You know me, I avoid negatives at all costs. So 3x minus 5y is equal to 4.5. And then you have to plug in the 1.5 for your y. 3x minus, and 5 times 1.5 gives me 7.5 equals 4.5. You add 7.5 to both sides, and 3x equals 12. Divide by 3, and x equals 4. 4, 1.5. That works. That's my answer. Can highlight it. We'll make it WVU colors for Aiden. He'll be excited. If I want to check my answer, all I have to do is plug this back in. And I obviously don't have a calculator that I can show you up here. But if you do negative 3 times 4 minus 8 times 1.5, it will equal negative 24. And if you do 3 times 4 minus 5 times 1.5, it will equal 4.5. So you can check your answer and always know that you have the right answer. Now, number 2. Problem number 2 is going to be a little bit different. If we have x plus 4y equal to negative 4, and x plus 10y equal to negative 16, and we add these together right here, combining them, that is going to give me 2x plus 14y equals negative 20. Now that's no good. It doesn't get rid of anything. I have to get rid of something. The whole deal is combination elimination. That didn't eliminate. So what I have to do is say, hey, this is an x and this is an x. If this were a negative x, then something would cancel. So I'm going to multiply everything on the bottom equation by negative 1. As long as you multiply every single term by negative 1, it's legal. Both sides of the equation. And the great thing about that is then something's going to cancel. Even better is that you get to use a distributive property. The first line is x plus 4y equals negative 4. It doesn't change because we're not distributing anything to it. The second line is negative 1 times x, or negative x, negative 1 times 10y, which is negative 10y, and negative 1 times negative 16. Negative times a negative, positive 16. And so now when I combined, we eliminate. X and negative x will cancel. This leaves me with 4y minus 10y, or negative 6y, and negative 4 plus 16, which is 12. Divide both sides by negative 6, and y equals negative 2. Halfway there, here's my answer down here. Y equals negative 2, but I still need an x. Does it matter? Absolutely not. I'm going to pick the first one. X plus 4y equals negative 4. I plug in for the y all the way over here. The x plus 4 stays the same, but the y becomes negative 2. And it's still equal to negative 4. X plus, and 4 times negative 2 is negative 8, equals negative 4. And you can look at this a couple of different ways. I know we talked about this in my e-block the other day. If you have plus a negative, you can subtract a negative, but subtracting a negative is just the same as adding 8, which will give me an x of 4. So 4 comma negative 2 is my answer. Very important. This is what I'm looking for, the solution, where the two lines intersect. We need to definitely do another one of those. So, sorry, I got a little bit interrupted. I am on number 3, and we are going to have 11x plus 14y equals 13, and 11x plus 10y equals 25. Now, you may say, wow, these numbers are ridiculous. Well, if you tried to graph this, if you tried to put them in slope-intercept form, I'm telling you, it is going to be a bit difficult. That's why we have other methods. That's why we have substitution. But once again, substitution, none of these are easy to isolate, but combination elimination is perfect. If I combine right now, just add them straight up, I get 22x plus 24y equals 38. Not helping. So I need something to cancel. Obviously, 11 and 11, if I make one of them negative, that will help. So I'm going to let's make the top negative this time. Doesn't matter. As long as you make one negative and one positive, then we're good. So now, here we go. Negative 1 times 11x is negative 11x. Negative 1 times 14y is negative 14y. Negative 1 times 13 is equal to negative 13. We don't multiply both of them. We have to keep our positive 11 down here. But now when we add combination, elimination, those go away. It also gives me negative 14 and a positive 10, which is negative 4y, and 13 plus 25, which is 12. When I divide both sides by negative 4, I find out that y is equal to negative 3. A big mistake we sometimes make is to stop there. Can't stop there. Doesn't matter which one we use. Let's use the second one this time. 11x plus 10y equals 25. We know y equals negative 3. And 11x plus 10 times negative 3 equals 25. 11x plus negative 30 equals 25. Add 30 to both sides. 11x equals 55. And you should get x equal to 5. That's what we want. 5, negative 3. Hopefully, you're getting the point. Hopefully, you're seeing that if both of them are positive, then you have to multiply by negative 1 to make one of them the opposite. I don't have a lot of time left, so I am going to do this particular problem, or at least I'm going to get started. I can't promise that I'm going to be able to finish. Well, highlighter is definitely not going to help me. Write down at least as far as I get. So we have 6x minus 9y equals 111. Who wants to graph 111? Not me. 5x minus 9y equals 103. When I add these two together, nothing cancels. But these are almost the same. You've got a negative 9 and a negative 9. Works exactly the same when they're both negative. If you still multiply by a negative, the top one stays 6x minus 9y equals 111. And then when I distribute my negative, I get negative 5x plus 9y equals 103. A negative times a negative is a positive. We say that all the time. This is supposed to be negative 103. I hope you caught that. A negative times a positive is a negative. A negative times a negative is a positive. And a negative times a positive is a negative. When I combined these two, 6x minus 5x is x. My 9y's cancel, and I get 111 minus 103, which is 8. Then you would just plug that one back in. We're not done, but that's all I got. Have a great night. I'll see you tomorrow.